Hi everybody, Cal here with section 4.2, null spaces, column spaces, and linear transformations. This is going to be a pretty big section for us. It's going to introduce a lot of the common subspaces of Rn that we're going to be playing with in this course. There's basically two kinds of subspaces that we're going to encounter here. The first is the null space of a matrix. And the null space is just the solution set for the homogeneous system AX equals 0. And that's defined right here in the middle of 201. It's all the vectors in Rn that get sent to 0 in Rn. Example 1 lets us play a little bit with a null space. And the theorem says that the null space is a subspace of Rn. Which, we would sort of hope if we're calling it a space. Anyway, the question that we're going to have here is, how do we describe the null space of A? So example 2 might be interesting. Read it, but it's not going to be a big one for us. How do we describe a null space? In other words, what we're going to want to do here is we're going to want to find a set of vectors so that the null space of A is the span of that set of vectors. And if we work through this solution, what you'll find is that the process of doing that is the exact same process as solving the system AX equals 0 in parametric vector form that we talked about way back in section 1.5. If we do that, then these vectors here that are cropping up in our parametric vector form are a spanning set for the null space of this matrix A. Not only that, but if you look at this blurb here, you'll find that it's a linearly independent spanning set. And you'll want to think about why that is. It'll be a useful concept for us in another section. So that's a null space. It's easily defined, and we know how to find a spanning set for it. And it's a subspace of Rn. The column space of a matrix is the set of all linear combinations of the columns of that matrix. Here's the definition. Or in other words, it's the span of the columns of A. That's the column space of A. The theorem says that column space of any matrix A is a subspace of Rm, if we have an m by n matrix. If you like, the column space is a subspace of the codomain of the transformation given by that matrix. The null space is a subspace of the domain. Moving onward, we have a couple of examples where we sort of play with column spaces. And the book talks about the contrast between the null space and the column space of a matrix, and this is a kind of important example to work through and sort of make sure that you understand what the differences are. Example 6 and 7 plays a little bit more with null spaces and column spaces. And what I want you guys to do is I want you to sort of think about, again, how will I find a linearly independent spanning set for the column space of a matrix? You might find hints in these examples. Finally, the book introduces something called the kernel of a transformation and the range of a transformation. We've seen range before. These will come up once or twice. They're not going to be huge for us, but this chart on the top of 206 is going to be really nice. The last couple of examples are a little bit different from things that we've seen before, but they'll be a little bit interesting. So, short one today. We're only covering one section on this IRAT, so that's all I've got for you here.